Those of you that are just joining us and you wanted to look at this again, we've done the first part of this oxidation worksheet, trying to find out what phosphorus is. We're now on PO3 with a -3. So we've set that up. We get x minus 6 equals a -3. What plus a -6 equals -3? Plus 3. Now if you have to solve it all the way down, that's okay. Okay, on the bottom one here, we're going to set up the same kind of thing. Phosphorus, we don't know, plus 4 times oxygen, we do know, equals -3. Well, x minus 8 equals -3. What's x got to be? Plus 5. So we found all of these now on the top. This next stage, they want you to find each one, not just one of them, but each one of them. So here, real quick, I can write down the ones I know. Sulfur, I don't know. But oxygen, I know is a -2. And I would go through all of these, writing down which ones I knew for sure. The next one is an element. It's part of Braun-Hifkel, or the twins, or the diatomics. We consider it an element, so it is 0. So Cl, its charge is 0. And I can go here, oxygen again is -2, oxygen again is -2. Carbon, I don't know. Nitrogen, I don't know. I can come back and look at them. Oh, potassium. Do I know potassium? +1. It's in the first column. I always know it. That means chlorine here has to be what? -1. Okay, so if I can do that real quick in my head, I'm not going to spend more time on it. Helium. Nothing. It's a 0. It's an element. Okay, nitrogen, I don't know here. Oxygen, I do know, is a -2. Hydrogen, +1. So can I find out what nitrogen is real quickly? What is it? -3, because I needed 3 positives to go with it. Okay, so I've done a lot of them. Let's go back to the first one. And we're going to set up again the algebra equation to figure it out. So I have 2 sulfurs, so 2x minus 3 oxygens. 3 times -2 equals 0. Well, 2x minus 6 equals 0. 2 times what is 6? 3. So this has to be a +3. Going with CO3 now, we've got unknown plus 3 times -2 equals a -2 this time. It doesn't equal 0 because it has a charge. Okay, did I lose you? You okay? Okay, what's your question? Oxygen, well, this was a plus. Sorry, yeah, it'll be a minus. Sorry, didn't realize I'd done that. Okay, so on this next one, we got x minus 6 equals -2. What? Adding a -6 is going to give me a -2. 4. So +4. On the bottom one here, nitrogen, unknown, plus 3 times -2 equals no charge, so 0. X minus 6 equals 0. What's x? +6. Okay, we're now at G. Now just looking at it, okay, I'm not going to do the algebra for it. Just looking at it, we have 2 oxygens. 2 oxygens times a -2 is -4. What do I have to add to that to equal 0? A +4. So I really didn't even have to do the algebra for it. Okay, so some of them you can do in your head. Some of them get a little complicated, especially like C with the negative added in. Do you feel confident? No. Okay, do you think you could find some? We're going to be doing some more. Okay, so then there's a whole bunch more on the back page like this that you can do. Now, here's a hint. If it has a polyatomic and you know the charge of the polyatomic, make life easy. Split it out and do the polyatomic separately. Use the polyatomic to find out what else it's with, its charge, but then split out the polyatomic by itself, like this is a -2 charge, and set it equal to that. So you don't have this big, long equation. You're trying to find all of them at once. And you might have 2 unknowns if you don't. Okay? All right, so if a substance is reduced, does it gain or lose electrons? This is where we use GR. Leo the lion says GR. So gain of electrons is reduction. Loss of electrons is oxidation. We can also use oil rig. Oxidation is loss, reduction is gain. What is this? Does it gain or lose electrons if it's reduced? It gains. Grrr. I become more negative. I'm going to go in the corner. I'm going to eat bonbons. I'm going to gain weight. Bonbons. Yep. So this is going to gain. Okay, if a substance is oxidized, I think of OxyClean. Oh, I've got rid of all the negative things with OxyClean, and I've become clean and positive. So this would be gained or lost electrons. The electrons are negative. This would be lost or lose. All the time, yep. So those are just some key things that help me to remember it, okay? If it helps you, great. If not, find your own thing. Now, on the next one, we're going to talk about oxidizing agent and reducing agent. So how do I determine between them? This is like that wedding that I was telling you about, bride and a groom. So if I'm the bride, I'm the groom agent, because I can't be a bride unless I have a groom. Okay, if the groom then is the bride agent, because he can't be a groom unless he has a bride. Right? So the oxidizing agent is reduced, and the reducing agent is oxidized. So they're opposite. Okay? All right, let's go on to the next part here, which is down at the bottom. We're going to do a simple one first, and then I'm going to throw in some other things here. Okay, so this one right here, all we have to do is identify the charges. So, hydrogen by itself, what charge? 0. It's an element. It's not with anything else. It hasn't gained or lost electrons. Chlorine by itself, 0. Now, when I put them together, they're going to give and take. So hydrogen's going to become a +1, and chlorine's going to become a -1. Now we can go through and say, okay, hydrogen has become more positive. So it is Leo, which is oxidized. Okay, and chlorine has become more negative. Grr. So it is reduced. So as we put this in then, if chlorine is reduced, it'll go here. And hydrogen is oxidized, it will go here. And then remember, it's opposite for the agent. So if I'm oxidized, I'm the reducing agent. If I'm reduced, I'm the oxidizing agent.
So how do you know that the hydrogen is going to be the positive?
Because it went from 0 to plus, so it became more positive.
Yeah, but how do you know that that's going to just from like
From our rules. The first column +1, second column +2, boron, aluminum +3, zinc +2, silver +1, fluorine's always -1, oxygen's usually -2. Everything else we have to guess. Now, if hydrogen was with any of those that had a specific charge, then it's forced to be a -1, and that's where we get hydride. But it wants to be a +1. Okay? All right, let's look at the back side here. I'm not going to go in order because I want to review ionic and net ionic with that too. So I'm going to, let's do E, and then I want to do H. So I'm going to have both of those up there. And I'm going to take and get me some paper because I want to be able to have a blank area where I can write these. Whoa, that's not the circle. I didn't want a circle. Let's try this again. I am having good times with this, let me tell you. Okay, we are just having so much fun, I can't stand it. Let's try this again. I am just drawing pictures for you. I hope you're enjoying that. Okay, that's what I wanted to do, well, except I didn't want to go that far. Okay, well, we're just... Okay, I want to do those two. Finally, okay. So, if I'm to write a net ionic equation from the top, I need to use my rules. I know that this is probably going to be AQ, and water is a liquid, and lead is a solid, and lead oxide is a solid, and this is AQ. Okay? Now, to do a total ionic equation, what do I split into ions? Always aqueous. Everything else stays the way it is. Okay, so I'm just going to split my aqueous. I'm going to get a different pen here. This one's really fat. So I'm going to split the first one into ions. So I'm going to have 2 Pb plus 2 aqueous ions. How did I figure out Pb was plus 2? Because sulfate is a minus 2. Okay, the 2 is going to go through. So I'm also going to have 2 SO4 2 minus aqueous ions. So I split the first compound. The second compound is water, and water doesn't split, so I'm just going to put water here as a liquid, and then my arrow. On the other side, lead doesn't split, so it's a solid, and lead oxide doesn't split, it's rust, plus, and I do split the sulfuric acid. So I'm going to get 4H plus AQ and 2 SO4 2 minus AQ. So this is a total ionic equation. Do I have a spectator ion? Do I have a spectator ion? One that is exactly the same on both sides. Is there any that are exactly the same on both sides? The 2 SO4s are exactly the same on both sides. So this and this are my spectator ion. So I would just go SO4 2 minus AQ is my spectator ion. So then, to do my net ionic equation, I take out the spectator ion. So I rewrite it as 2 Pb plus 2 AQ plus 2 H2O liquid goes to Pb solid plus PbO2 solid. Sorry, that last B is sort of weird. Okay, so there's a quick review of overall ionic and net ionic and how to pick out the spectator. Now, I've got to figure out what's oxidized and what's reduced. Yes?
How come we don't have to write the 4H?
Oh, I forgot it. Sorry. Yes, we do need to write the 4H plus. Thank you. I just got tired of writing, I guess.
So I'm still a little confused on how we find the AQ or S.
Okay, usually they'll tell you it's a solution. I just went through and told you what it was. But remember our solubility rules? NAGSAG. Okay, lead sulfate actually is part of the PMS and the exceptions, but is partly soluble. So it's going to be aqueous in order for it to, because it's in water, in order for it to react. Okay, so that's why it's AQ. And then H2SO4 is an acid, and we've worked with it before. It has to be aqueous. It has to be in solution. Lead and lead oxide are the plates in your car batteries. So you probably didn't know all that, but I just gave it to you, and it would be given to you in Word. Like lead oxide is solid, lead is a solid. So, and most of the metals on the periodic table are solids, right? The only liquid is mercury. And then there's very few gases, and if you know what they are, you can just go, oh, nitrogen, oxygen, fluorine, and chlorine, okay, and the noble gases. Bromine's a liquid, so there's only 2 liquids on there. One's a metal, one's a non-metal, okay? All right, so now we need to figure out which is oxidized and what's not oxidized. So this is what I would not write in my net ionic equation, but I need to know. So I'm going to do it in red. So that actually, let's do it a different color because we already used red. Let's use this funny pinky purple. Okay, so I already have this first one, lead is plus 2. I know that hydrogen's a plus 1. I know that oxygen's a minus 2. I know that any element by itself is 0. Okay, I know oxygen's a minus 2. There's 2 of them. That makes minus 4. That means the lead has to be a plus 4. And I've got the hydrogen. If I look at this, lead, I've got 2 of them. One of them is going to go to the 0, and one of them is going to go to the plus 4. So lead here is both oxidized and reduced. Yes?
How would the 4H be a positive? Is it by itself?
Right, but it was part of the H2SO4.
Oh.
Okay? So what lead is being oxidized? The one going to 0 or the one going to +4? Just tell me which one's oxidized. +4 because it's becoming more positive. So this is oxidized. Remember, it's becoming more positive. It doesn't have to start as a negative, but just becomes more positive. That means this one's becoming more negative because it was a +2 and now it's a 0. So it's lost things. So this one is being reduced. So on this one, since they're all lead, I just put lead in everything. Lead is oxidized, lead is reduced. Lead is the oxidizing agent, lead is the reducing agent. Lead is everything. Lead is everything to me. No. Okay, so let's look at this next one. Again, I want to write the overall ionic, and I want to write the net ionic. And I want to know what spectator ions there are. There are questions like this. Okay, so anything that is by itself is a metal, is a solid. Nitrates are always soluble, so this is going to be AQ, and this is going to be AQ. And copper, we know, of course, is a solid. Right? So going through, magnesium as a solid plus copper nitrate's going to split. We're going to have Cu plus 2 because nitrate is a -1 and we needed 2 nitrates to balance it. AQ because it's an ion plus 2 nitrates that are each -1 as AQ. Cute little ion. Yields, magnesium nitrate's also going to split. Magnesium is going to be a +2 AQ, and we're going to have 2 nitrates. And we're going to have copper out by itself as a metal. Okay. Spectators. It has to be the same on both sides. So what is the same exactly on both sides? The 2NO3 is exactly the same on both sides, right? So that is our spectator. I should put it. We only have one spectator here, and it is nitrate. Everybody following so far? Okay, so now I'm going to go to my net ionic equation where I draw up the spectators. So it becomes magnesium as a solid plus copper plus 2 as an aqueous goes to magnesium plus 2 aqueous plus copper as a solid. Well, I can see really quickly what's oxidized and what's reduced here, can't I? Because any element by itself is 0. So what's my oxidized? What's becoming more positive from the reactant side, which is the left side, to the product side, which is the right side? Magnesium. So magnesium is oxidized. Because it's oxidized, it's my reducing agent. What's being reduced? Becoming more negative. Copper. So I'm going to go copper is reduced, and it is my oxidizing agent. We go okay? Okay, now at the very bottom of this worksheet, and notice I'm not doing everything with you. I'm just doing some. But this is a good review worksheet. It tells you really quickly to look and see if something is a redox reaction or not. Here's a big key. If I have any elements by themselves, any elements whatsoever by themselves, it's a redox reaction because I have 0 on an element. And then it goes to a compound and it has to have a charge. Okay? So right there I can, without doing anything else, I just look for elements by themselves. That's a redox. Okay? The ones that don't know for sure are like the double displacement. They possibly could be. They could force it to a different charge. So I just need to check and see. Is that, are they the same charge? Does a polyatomic stay together the exact same? If it does, I know the charge of each one is the same. So IO3 here and IO3 here stay the same, right? It doesn't change to IO4 or IO2. That would change the I's charge. So I can do some quick things like that. I know potassium is the same, it looks like on both sides. Barium is the same. So this one doesn't look like it's a oxidation reduction. The key here is on polyatomics, if the polyatomic changes side to side, then I know something changed in the charge. So if I go from an SO4 to an SO2, or if I go from a ClO3 to a ClO, I changed the charge on the chlorine. The oxygen didn't change, but the chlorine charge did. Okay, so those are just really quick ways to look and see if it's a redox reaction. Okay, then on the very, very back page, I left you with some more more compounds that you can practice doing. Now, remember my little trick here. If I don't want to put all these together, like on this one, I can look and I say, oh, potassium is a +1. I know that already. That means MnO4 is a -1, so I'll just set MnO4 to the -1. So I don't have to deal with the +1. I already know potassiums, right? Rather than have 3 things in my algebraic equation that I'm solving for, I can only do 2. Makes it easier, okay? All right, so these are just some to practice. It is not something that you have to hand in. If you're not getting this, this is a great way to finally get it. Come up and say, Mrs. Howell, am I doing this right? And if I'm not doing it right, what did I do wrong, kind of thing. These are on there. You need to be able to do this, okay? You need to be able to tell me the charges. You need to be able to identify oxidation, reduction, oxidizing agent, reducing agent, okay? All that. Questions? Okay, the rest of the time is going to be yours. I'll bring you back together about 5 after, because about 5 after we'll start coming back together for the exit quiz, okay? So that we have enough time to do that. There are 10 questions in the exit quiz. It's about this stuff and the stuff on this chapter, okay? Questions? All right, great. We'll stop this and